Welcome to MasterCode. In this tutorial, I am going to walk through the complete process of setting up a professional ethical hacking lab using VMware Workstation Pro 17. I will load two virtual machines, Kali Linux as the attack machine, and Metasploitable 2 as the intentionally vulnerable target machine. By the end of this video, both machines will be running inside VMware, and I will test whether they can communicate with each other over the virtual network. Let us begin. You can see VMware Workstation Pro 17 is open on the screen. I right-click on the title bar of the VMware application window. A context menu appears showing the standard window management options: restore, move, size, minimize, and close. I use this menu to reposition the VMware window before starting. The VMware Workstation Pro 17 home screen is now fully visible. In the center of the screen, you can see three main action buttons: create a new virtual machine, open a virtual machine, and connect to a remote server. On the left side is the library panel, which is currently empty because no virtual machines have been added yet. I am going to click on Open a Virtual Machine to begin adding the first virtual machine. A file browser dialog has now opened. This is the VMware Open dialog box. I am browsing through the file system to find a virtual machine file. You can see the navigation panel on the left side of the dialog showing drive and folder shortcuts. I am navigating inside the OS folder on the local drive. Inside this folder are various virtual machine image files stored for different operating systems. I have selected a file, a VMDK file called Kali Linux 2026.1 VMware AMD 64S003.vmdk. However, an error dialog has immediately appeared on screen. The error message reads, the file Kali Linux 2026.1 VMware AMD 64S003.vmdk cannot be opened directly. Please open the virtual machine configuration file.vmx instead. This is an important point to understand. The VMDK file is the virtual hard disk. It contains the operating system data stored inside the virtual disk. You cannot open VMDK files directly in VMware. You must open the .vmx file instead. The .vmx file is the main configuration file for the virtual machine. It tells VMware everything it needs to know: how much RAM to use, what hard disk to attach, which network adapters to configure, and all other virtual machine settings. I click OK to dismiss this error message. I am now using the new virtual machine wizard in VMware. The wizard dialog has appeared on screen. The current step shows the guest operating system installation options. The three choices visible are: install the operating system from a disk or image, use a physical drive, or install the operating system later. I select the option to install the operating system later. This is the correct choice because I already have a pre-built virtual machine image downloaded. There is no need to install a fresh operating system from scratch. I continue through the wizard steps. The wizard is now showing the file browser to locate the virtual machine configuration file. I navigate inside the Metasploitable 2 Linux folder. The specific file needed is named Metasploitable.vmx. This is the VMware configuration file for the Metasploitable 2 virtual machine. After selecting this VMX file and completing the wizard, VMware has all the information it needs to register and manage this virtual machine. The Metasploitable 2 Linux virtual machine summary page is now displayed inside VMware. This page shows all the configuration details. Reading the key information from this page, the virtual machine status shows powered off. The RAM allocation is 512 megabytes. The hard disk size is 8 gigabytes. Two network adapters are configured. The first is and the second is set to host-only mode. Are also displayed: username svadmin, password svadmin. In the VMware library panel on the left side, Metasploitable 2 Linux has now appeared, confirming it has been successfully registered. I switch to the My Computer tab inside VMware. This view shows all registered virtual machines on this computer. Metasploitable 2 Linux is visible here as well, listed and ready to use. Back on the main VMware screen, the Metasploitable 2 Linux tab is active in the main content area. I now click the power on this virtual machine button to start Metasploitable 2. The startup indicator appears on screen as VMware begins initializing the virtual machine and allocating the RAM and virtual disk resources. The Linux boot process is now underway inside the Metasploitable 2 terminal window. Boot messages are scrolling across the screen. First, you can see the file system check running. FSCK is verifying the integrity of the virtual disk partitions before mounting them. This is a normal and important part of the Linux startup process. After the file system check passes, you can see the system mounting the local file systems. Then the system begins configuring the network. Messages appear showing that the network interface F0 is being brought up and assigned its IP address. Following the network setup, services begin starting one after another. You can see these services loading in sequence. Port map is starting, NFS common utilities are initializing, the OpenBSD secure shell server is starting, Apache Tomcat web server is starting, and Apache 2 web server is starting up. The boot sequence continues. On the right side of each service startup line, you can see the square bracket OK indicator appearing as each service successfully starts. These services, including FTP, SSH, web servers, Samba, and database servers, are the intentionally vulnerable services that make Metasploitable 2 such a valuable practice target for security testing. Now the Metasploitable 2 ASCII art logo appears on screen. The word Metasploitable is displayed in large text art characters. Directly below this logo, a critical warning message is displayed. It reads, "Warning, never expose this virtual machine to an untrusted network." This warning is extremely important. Metasploitable 2 is intentionally configured with dozens of well-known security vulnerabilities. If you ever connect this machine to a real network or to the internet, those vulnerabilities could be exploited by anyone who can reach it. Always keep Metasploitable 2 inside VMware's private virtual network, which is completely isolated from your physical network and from the internet. Below the warning message, the login instructions are shown. Log in with mspadmin and password mspadmin to get started. The login prompt has now appeared on screen. The terminal shows, Metasploitable login. I type the username mspadmin and press enter. The password prompt appears next, and I type the password mspadmin. The password characters are hidden as they are typed. This is standard Linux security behavior where passwords are never displayed on screen. After pressing enter, the system verifies the credentials and accepts them. The Metasploitable 2 shell prompt is now visible. It shows, mspadmin at Metasploitable, followed by the $. This confirms that Metasploitable 2 is fully running and accessible inside VMware. The target machine is now operational and ready. This completes the first phase of the lab setup. Now I move to the second phase. Back on the VMware Workstation home screen, Metasploitable 2 Linux is listed in the library panel on the left. There is currently only the Metasploitable 2 tab visible in the main panel. Now I need to add Kali Linux, which will be the attack machine. I click on File in the VMware menu bar at the top of the window. A drop-down menu appears, and I select Open. This opens the file browser dialog directly, which is the quickest method to add a pre-built virtual machine to VMware. The file browser dialog is now open. I am navigating through the file system. In the left sidebar of the dialog, you can see the drive shortcuts. I navigate to the E drive, then into the OS folder. Inside the OS folder, there is a subfolder named Kali Linux 2026.1 VMware AMD 64. I open this folder. Inside, several files are visible that belong to the Kali Linux virtual machine. I locate the file named Kali Linux 2026.1 VMware AMD 64.vmx. This is the VMware configuration file for Kali Linux. The AMD 64 in the file name means this is the 64-bit version, which is the correct version for all modern computers. I select this VMX file and click Open. The Kali Linux 2026.1 virtual machine summary page. Reading the configuration details shown on screen, the memory is set to 2 GB of RAM, the processor is configured with 4 CPU cores, the hard disk size is 80.1 GB, and the network adapter is set to NAT mode. The login credentials for Kali Linux are also shown. Username is Kali, password is Kali. The configuration file path shown at the bottom reads, e:/os/Kali Linux 2026.1 VMware AMD 64, followed by the VMX file name. I now click the Power on this virtual machine button. The Kali Linux Grub bootloader screen appears. Grub is the boot manager that runs before the operating system loads. You can see the Kali Linux boot menu with the default option highlighted at the top. A countdown timer is visible showing booting in 3 seconds. As the timer counts down to 0, the default boot option is automatically selected and the Kali Linux boot sequence begins. Now Windows File Explorer has opened on screen. I have navigated to the folder on the E drive that contains the Kali Linux VMware files. You can see the contents of the Kali Linux 2026.1 VMware AMD 64 folder. Among the files and folders visible, there is a subfolder named Kali Linux 2026 W22 Hyper-V AMD 64. This is the Hyper-V edition of Kali Linux, a completely different virtualization format designed for Microsoft Hyper-V, not for VMware. Since this lab uses VMware exclusively, this Hyper-V folder is unnecessary and is consuming a large amount of storage space on the drive. I select the Hyper-V folder and press the delete key. A Windows confirmation dialog appears. The message warns that this item is too large to be sent to the recycle bin and will be permanently deleted from the disk. I click Yes to confirm the permanent deletion. Windows begins removing the Hyper-V folder, freeing up the storage space on the hard drive. While the deletion process is in the background, I switch back to VMware. Kali Linux has been booting during this time. The Kali Linux graphical login screen is now appearing inside the VMware window. Looking at VMware, both virtual machines are now visible in the library. Kali Linux 2026.1 is booting, and Metasploitable 2 Linux is also present. The Kali Linux desktop has now fully loaded. On screen you can see the Kali Linux 2026.1 desktop environment. The desktop wallpaper displays the Kali Linux Dragon logo. 3 desktop icons are visible, the home folder icon, the file system icon, and the trash icon. The top panel shows the Kali Linux application launcher menu on the left and system status indicators on the right. Kali Linux is now the fully operational attack machine, pre-installed with hundreds of security and penetration testing tools. I briefly open the VMware file browser dialog again on screen, visible for a moment, before returning to the main VMware interface. Back on the VMware home screen, you can now see both virtual machines are listed. Kali Linux 2026.1 and Metasploitable 2 Linux both appear in the library panel on the left and as tabs in the main content area. I now right-click on the Metasploitable 2 Linux entry in the library panel. A context menu appears with several options. I move the cursor to Power. A submenu expands showing the power management options: Power On, Shut Down Guest, Restart Guest, Suspend, and Power Off. I click Shut Down Guest, which sends a clean software shutdown signal to the Metasploitable virtual machine, allowing it to power down gracefully. After the shutdown completes, the status of Metasploitable 2 Linux changes to Powered Off. The My Computer view inside VMware now shows both virtual machines, Kali Linux 2026.1 and Metasploitable 2 Linux, and both are displayed with a powered off status. This is the correct state before making network configuration changes. Looking at the Metasploitable 2 Linux summary page, two status messages appear. First, initializing virtual networks. Then, loading network configuration. VMware is initializing the virtual network services and loading the existing network settings associated with the virtual machines. I now open the Virtual Network Editor from the VMware Edit menu. The Virtual Network Editor dialog box opens on screen. This is the essential tool for configuring how virtual machines communicate with each other inside VMware. The dialog shows a table listing all the configured VNet virtual network adapters. Reading the network configuration table on screen. VNet 1 is configured as NAT mode. Its subnet address is 192.168.100.0 with a subnet mask of 255.255.255.0. VNet 2 is configured as a custom network. Its subnet address is 192.168.50.0. VNet 3 is configured as host-only mode. Its subnet address is 192.168.227.0. I am now adjusting the subnet IP address assignments for these VNet adapters. Each VNet adapter represents a completely separate and private virtual network that only exists inside your computer. Virtual machines assigned to the same VNet adapter can communicate with each other. Virtual machines on different VNets cannot communicate without a router connecting those networks. I make the configuration adjustments and click Apply to save the changes. VMware then restarts the virtual network services to apply the new configuration, which takes a moment to complete. I now open the virtual machine settings for the Metasploitable 2 Linux virtual machine. The Virtual Machine Settings dialog appears, showing the Hardware tab with all the installed virtual devices listed on the left side. Looking at the device list, the CD/DVD drive is present, Network Adapter is listed and configured as NAT mode, and Network Adapter 2 is listed and configured as host-only mode. These two network interfaces define how Metasploitable connects to the VMware virtual networks. I review these settings. A new dialog box has appeared on screen. The title reads Side Channel Mitigations. The message explains, you are running this virtual machine with side channel mitigations enabled. Enabling mitigations may reduce performance but increases security against certain hardware-level vulnerabilities. I click OK to close this informational dialog and continue. After dismissing this dialog, VMware begins rebooting the Metasploitable 2 virtual machine to activate the updated network configuration. At the same time, Kali Linux is starting its boot sequence. The Kali Linux boot animation appears on screen. The iconic Kali Linux Dragon logo is displayed in the center of a dark loading screen as the operating system initializes and loads its system services in the background. Kali Linux has now reached the graphical login screen. The login interface shows the username field. I click on the password field and type the Kali Linux login password. The characters are replaced by dots in the password field as they are entered, keeping the password hidden. I then click the login button to complete the login. Kali Linux 2026.1 desktop is now fully loaded inside VMware. The desktop wallpaper shows the Kali Linux Dragon logo. On the desktop, the icons for Home, File System, and Trash are visible. The top taskbar shows the Applications menu, the Places menu, and the System menu on the left side, along with the system clock and network status indicators on the right. Kali Linux is now the fully operational attack machine running inside VMware with all its tools ready to use. Meanwhile, Metasploitable 2 is going through its second boot sequence after the network reconfiguration. The boot messages are visible in the Metasploitable terminal window. Services are starting again. Apache Tomcat and Apache 2 Web Server are starting and showing OK status on the right. The Metasploitable 2 ASCII art logo appears again on screen. The warning message follows, warning, never expose this virtual machine to an untrusted network. Below it, the login instructions appear again, login with msfadmin and msfadmin to get started. The Metasploitable login prompt appears on screen. I type the username msfadmin and press enter. The password prompt appears, and I type msfadmin again. After pressing enter, the login succeeds. The Metasploitable shell prompt appears, msfadmin at Metasploitable, followed by the $sign. Metasploitable 2 is now running again after the network reconfiguration. Now I need to verify the actual IP addresses that have been assigned to each virtual machine. I am working in the Metasploitable 2 terminal. The command I type is ifconfig. This is the interface configuration command in Linux. It displays the current network configuration for every network interface installed in the system. After pressing enter, the output is displayed on screen. Looking at the ifconfig output for Metasploitable 2, the F0 interface entry shows init address with the value 192.168.45.128. The network mask shown is 255.255.255.0, meaning this machine is on the 192.168.45.0/24 subnet. Metasploitable 2 has been assigned the IP address 192.168.45.128. Now I switch to the Kali Linux machine. I open a terminal window in Kali Linux and type the same command, ifconfig. After pressing enter, the network interface output for Kali Linux appears on screen. Looking at the F0 interface for Kali Linux, the init address shows 192.168.50.130 with a netmask of 255.255.255.0. Kali Linux is on the 192.168.50.0/24 subnet and has been assigned the IP address 192.168.50.130. I now have the IP addresses for both machines confirmed. Kali Linux is at 192.168.50.130 on the 192.168.50.0 network, and Metasploitable 2 is at 192.168.45.128 on the 192.168.45.0 network. These are two completely different subnets. I am now going to test connectivity between the two machines using the ping command. In the Kali Linux terminal, I type ping 192.168.45.125, targeting an address on the Metasploitable subnet. I press enter and watch for the result. The result appears on screen immediately. The output reads, ping, connect, network is unreachable. This tells us that Kali Linux has no route to reach any address on the 192.168.45.0 subnet. There is no path between these two machines. Now switching to the Metasploitable terminal. I type the reverse ping 192.168.50.130, targeting the Kali Linux IP address directly. After pressing enter, the same message appears, connect, network is unreachable. Metasploitable cannot reach Kali Linux either. This result is expected given the current network configuration. Kali Linux is on one VNet adapter using the 192.168.50.0 subnet, and Metasploitable 2 is on a different VNet using the 192.168.45.0 subnet. Without a router configured between these two different virtual networks, neither machine can reach the other. The ping command confirms this with the network is unreachable error. This is a fundamental networking concept. For two machines to communicate directly without a router, they must be on the same subnet. When machines are on different subnets, a router is required to forward packets between the networks. In this lab, the solution is to reconfigure the VMware Virtual Network adapter settings so that both Kali Linux and Metasploitable 2 are connected to the same VNet adapter. Once both machines share the same subnet, for example, both connected to VNet 2 on the 192.168.50.0 network, the ping test will succeed and all network communication between the attack machine and the target machine will work correctly. This video has demonstrated the complete process of setting up a VMware ethical hacking lab. You have seen how to add pre-built virtual machines to VMware using the Open Virtual Machine option and the File menu, how to work through the new Virtual Machine Wizard, how to boot and log into Metasploitable 2 using its default admin credentials, how to import and start Kali Linux 2026.1, how to delete unnecessary virtual machine files to free up disk space, how to use the VMware Virtual Network Editor to review and configure virtual network adapters, how to check the virtual machine settings for network adapter assignments, and how to use the ifconfig and ping commands in Linux to check IP addresses and test network connectivity. Thank you for watching MasterCode. If this tutorial was helpful, please subscribe to the channel and share it with others who are learning ethical hacking and cybersecurity. In the next tutorial, I will correct the subnet configuration so that Kali Linux and Metasploitable 2 can communicate, and then begin our first penetration test.